These are the notes for 3C, Lesson 2. I'm going to jump around on some of these problems today. We're going to skip some, and I'm also going to have you try some, and at those points, feel free to pause the video. Now we don't have an inequality statement, right? So if I zone in on number 1 here, instead of having like x is greater than 10, I have x plus 8 is greater than 10. Here we're just going to use our algebra skills, right? I want to get rid of that plus 8. I'm going to subtract 8 from both sides. I get x is greater than greater than 2. If you want, you can put this anywhere on the number line. If you want to put a 0 for your reference, that's fine. But I'm just going to put this here. And I just want to leave myself a little bit of space. I'm shading those numbers to the right. The 0 is not necessary, but it's probably a good idea to at least know, especially when we start graphing these compound inequalities, where that 0 is. Here we're just going to add 4 to both sides. We'll get x is less than -2. Again, less than or equal to -2. Put that wherever you want. Just make sure that you plot that -2. Put a circle there and make sure it's closed. And then to get this x by itself, we're just going to divide both sides by 3. So we're just kind of treating this like an equal sign. And then when we get to the end, instead of having a solution, we have this set of solution, right? All the numbers less than 6. Here, we're dividing by 2, so we're just going to multiply both sides by 2. Just be careful on this one. And again, that inequality stays the same. We're greater than or equal to 24. It doesn't matter if that's a pretty big number. We can graph that wherever we want. All right, so we're just using our basic algebra skills. Now, our first rule here is there is one kind of different thing with inequalities. Whenever we multiply or divide by a negative, we have to flip the inequality symbol. So we'll see that happen in some of these other equations down here, right? We're going to solve them. We'll have multiple steps, but we're going to see that if we have a negative number, we're going to have to flip that inequality. All right, now not all the time. So if we look at this first equation, right? If this was an equal sign, think about what we would do, right? We put a little divider up there, and we always want to get rid of that addition or subtraction first. So I'd subtract 3 from both sides, and then we're just going to divide by 5, right? So this looks exactly like what we've done with our two-step algebra problems, right? Except now it's an inequality. I just need to be on the lookout for that flipping of the inequality in case I divide or multiply by a negative. All right. If you want, pause the video here, try 2 and 3 real quick, and then we can look at the solutions. Okay, looking at 2, right, we have a 2-step. We're going to add 1 to both sides, divide by 4. Again, we do not flip this inequality. This is where things get tricky. A lot of times we're worried about flipping or not flipping. That -32 is just a -32. The 4 that I'm dividing by is positive, so that's why I do not flip the inequality here. It's still less than. Over here we have distribution, right? We distribute, okay, and then we add the 8, and then we divide by 2, and I get x is less than or equal to 9. All right, so pretty basic stuff, just 2-step equations to solve. Now, number 4, this is where things are going to get a little bit different, right? We're going to take care of this addition or subtraction first. So we'll have -3 is greater than 18. And then we divide both sides by -3. And here is where the flip occurs. This is going to go from a greater than to a less than, -6. So then I'm open at -6, and we're going to the left forever. So that's what it looks like to flip. And again, why did I flip? I flipped because of this -3 down here, right? It doesn't matter if the number is negative. It's the number that I'm dividing by that's important. Okay, now we're going to look at some more complicated problems. And with more complicated problems, a lot of times we'll have variables on both sides. What I would like to do is I would like to keep the variable on the left-hand side because it's easier to read left to right than it is right to left. We'd have to rearrange stuff. So what I would recommend when you see a problem like this, I'm going to take this inequality and I'm going to rewrite it. Okay, so the left-hand side and the right-hand side are switched. Now, here's where you have to be really careful. The way that I look at this is this inequality is pointing at 15, right? I know that says less than, but I just want to think of it, it's pointing at 15. So when I rewrite this, I want to make sure my inequality is still pointing at negative 15. And now I can do my algebra, subtract 3 from both sides, get x is greater than or equal to negative 18. We divide by 2, no flip here, right? Don't let that negative 18 fool you. And x is greater than or equal to negative 9. Okay. And then you could see number 10. I mean, I'll leave that solution up there for a second, but this is just a slightly more complicated. We're distributing that negative. You could see right here on this step as I'm doing this problem, right? This happens. This is why I like to flip, because if I try to do negative 7 is greater than k, if you look at my rewrite here, I rewrote that with the k on the left, the negative 7 on the right, and that inequality is pointing at k. What that is actually saying is k is less than or equal to negative 7. So if you're just straight up reading that greater than, you would think we're shading to the right, but the variable is not in the right in the right spot. So you can change it at the end. I think it's probably best to just change it at the beginning and then kind of roll through that problem. Now, if you have variables on both sides, I would recommend, this is where we have like some control without having to rewrite the problem. I would keep the variable on the left-hand side. So on this problem, I think if this were a regular algebra problem, a lot of people would want to add that 5 to keep the coefficient positive. But I think with an inequality, it's just too easy to read that inequality incorrectly. So you can see here, I add 4x to both sides, so that gets my x on the left-hand side. We subtract 24 from both sides. Okay, now I'm not done here. This is actually kind of a little subtle step here. I'm going to divide by negative 1, which means I have to flip that inequality. So it's x is less than 4. We leave it open. Okay, so the idea here is we want the variable on the left if we can control that. That may require us to rewrite the problem. The homework associated with this lesson is 3C Worksheet 2. Thanks for watching the video.